Okay, in this video, we're going to talk about how to graph cosine curve. And we're going to be putting it onto our x, y axis. And for this first lesson, we're going to talk about what it means to be a equals a cosine bx. That's the form we're going to look at. We will eventually look at what happens if we add, d, some number out here. But for this lesson, we're not going to do that. So let's just start with y equals cosine x. That would mean my a value is 1 and my b value is 1. The coefficient, this a value, is what we refer to as the amplitude of a graph. That's how high or low it comes off of its axis of oscillation. This b number, the coefficient of x, is also 1 in this problem. And it helps me to find the length, or how long it takes one cycle to happen, or one period. And it's found by taking 2 pi over b. And the reason we use 2 pi is because the unit circle, one complete revolution, is 2 pi in terms of radians. So this graph, y equals cosine x, has an amplitude of 1. Its b value is 1, which makes its period 2 pi. Whenever we have a period, we always divide it into fourths. That's because there's 4 quadrants. So if you look at my scale here, I went pi over 2, that's quadrant 1. From pi over 2 to pi is quadrant 2. From pi to 3 pi over 2 is quadrant 3. And from 3 pi over 2 to 2 pi is quadrant 4. So it's divided into quadrants. I also marked my amplitude as 1 and -1. Amplitude is a vertical stretch or compression. Period is a horizontal stretch or compression. Okay. Then down here at the bottom, I actually made an XY table. And from my unit circle, if x is 0, y was 1. If x was pi over 2, y was 0. Pi, -1, and so forth. So for cosine, if my x value is 0, my y value is 1. If x was pi over 2, my y value was 0. If it was pi, it was -1. If it was 3 pi over 2, it was back to 0. And at 2 pi, we completed one complete cycle, or one complete period. So the graph of cosine is that upside down U-looking thing. This x-axis is what we call the axis of oscillation. If we do vertical shifts, that will change. But cosine, understand, started at its amplitude and then went down to its axis. When we get to sine, it's going to change. So cosine kind of looked like an upside down U. If I continued around the unit circle, kept doing coterminal stuff, this cosine wave would continue itself as well. And I could do it in a negative direction.